All right, so our topic for today, we're going to be looking at some parallel lines cut by transversal, but this time we're going to be focusing on solving for different angles. And our essential question that we're going to try to answer by the end of this video, how can I use angle relationships to solve equations when parallel lines are cut by transversal? Easy enough. So from last time, you might remember that when lines are cut by transversal, 8 different angles are formed. And all 8 of these angles, if you look at a pair of them, they're either congruent or they're supplementary. And so one thing that we kind of discovered last time was that we've got this different little pattern going on here. So I'm going to color code some things. I recommend that you do so as well. When we do this color pattern here, all of our yellow angles will be equal to each other. So yellow will be equal to yellow. All of our green angles will be equal to each other as well. So green is equal to green. And if you pick any yellow angle and any green angle and you add them together, they're supplementary. So a yellow and a green are supplementary, a yellow and a yellow are congruent, a green and green are congruent. And this little color pattern will help us out immensely when we're trying to come up with the equations that we'll be able to solve. So our examples here today, we're just going to be trying to name these angle pairs that we see, practice the naming process, and remembering the relationships being used. So example 1 here says determine the angle pair and solve for the variable. If we quickly do the color pattern here, we should be able to see that they are both yellow, which means that they are going to be congruent, which means that we're going to set them equal to each other. And if we remember our names, those are both kind of in the same spot. They're both in the bottom right. So those are our corresponding angles. Now, like I mentioned, our equation here will be to set them equal to each other because corresponding angles are congruent and because they're both yellow. So I set up my equation and let's get solving here. I like to get my x's on the left side. So I'm going to subtract the 20x. It's going to give me negative 3x plus 10 is equal to negative 5. If I subtract the 10, I'm going to get negative 3x is equal to negative 15. Divide by negative 3, and I'll get that x is 5. Let me plug that back in to make sure that that works. If I plug it back in, 20 times 5 is 100, minus 5 is 95. 17 times 5 is 85, plus 10 is 95. So they're both 95, so I'm going to give myself a check because that's what I expect. That's how I would expect that to work out. So I've checked my work. I know that I got my answer right. Example 2, let's do the same thing here. I'll start off with a little color pattern. Yellow, 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 yellow. Green, 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 green. Looking at this angle pair, I see that they're both on the outside of my parallel lines and that they are on different sides. So this is going to be alternate exterior angles. And since they're both the same color, I can set these things equal to each other. So 7x plus 2 is equal to 38 minus 2x. Alternate exterior angles are always supposed to be congruent. So we got our equation, let's solve. Adding 2x over gives me 9x plus 2 is equal to 38. Subtracting the 2 gives me 9x is equal to 36. And that should give me that x is 4. Let's plug that back in and make sure that that works. If x is 4, 7 times 4 is 28, plus 2 is 30. And then 38 minus 2x, 2 times x, 2 times 4 is 8. 38 minus 8 is 30. So I'm giving myself a check because that all worked out. I checked my work. All right, let's keep cruising. On the inside of your notes there, we got example 3, determine the angle pair and solve for the variable. So same deal here. Color pattern time. Okay, so they are different colors, which means that they're supplementary. And that makes sense because those angles are both on the inside but they're both on the same side of the transversal. So these are same side interior, which is our angle pair that's supposed to be supplementary. So we're going to do 2x plus 15 plus 65 is equal to 180. Remember, supplementary means that they add up to be 180. If I combine my like terms, 15 and 65 make 80. Subtract that 80. Get 2x is equal to 100. And dividing by 2 gives me 50. So let's check our work. Let's plug that back in. Oh my goodness. I completely goofed. I'm sorry. That should not have been a 2x. That should have been a 25x. Oh my. Hopefully you guys caught that. So that's 25x. So what's going to happen here? So that should be 25x is equal to 100. So that's x equals 4. I was testing you guys. Hopefully you caught it. So x is 4. So let's plug that back in and see if that works. 25 times 4 is 100. 100 plus 15 is 115. Does that work? 115 plus 65, does that equal 180? It does. So now we give ourselves a check. So that's always why we check our work, right? If I had just blindly gone with 50, ooh, that would have been rough. Okay, we passed that one. Let's go to example 4. Determine the angle pair, solve for the variable. So let's do a little color pattern. What do we see here? They're the same color, so they should be congruent, which makes sense to me because these are alternate interior angles, right? Alternate interior angles are supposed to be congruent if the lines are parallel, which we're assuming that these lines are parallel. So we set them equal to each other. Same color, they're equal to each other. Congruent means they're equal to each other. We jot that line down. Let's subtract that 3x. I'm left with 2x's minus 50 is equal to 10. We'll add the 50 over. We'll get 2x is equal to 60. Divide by 2 and get that x is 30. Okay, let's double check our work, right? We know what happened on that last one. Let's plug that back in. So 3 times 30 is 90, plus 10 is 100. 5 times 30 is 150, minus 50 is 100. So give ourselves a check. We checked our work. We made sure that answer was right. Okay, example 5. Determine the angle pair, solve for the variable. What do we got here? Color pattern. That shows that they're the same color, which means that they're going to be congruent. Means they're going to be equal to each other. And that makes sense to me because those are both in the same spot, meaning that those are corresponding angles. So let's set those equal to each other. 9x plus 11 is equal to 12x minus 22. Get all those x's on the left side. It's going to give me 3x plus 11 is equal to negative 22. Subtract that 11. We get 3x is equal to negative 33. Divide by 3. I'm sorry. That should be a negative 3. Divide by negative 3, and we get that x is 11. Okay, let's plug that back in, double check our work here. 9 times 11 is 99. Plus 11, 99 plus 11 is 110. 12 times 11 is 132. 132 minus 22 is 110. So we give ourselves a check. They ended up being congruent. Okay, what do we have up here? Ooh, so we got more than one variable on this one. We got an x and a y. Solve for the variables. Okay, so in a case like this, let's definitely do the color pattern. See what relationships we can see. Okay, so which ones are the same color? The 4x plus 40 and the 11y plus 10 are the same color. But setting those equal to each other won't really work because it'll be an x equal to a y. We can't solve that. So what's going on with the two that only have x's? The 4x plus 40 and the 4x minus 20. Those are different colors. So that's going to be a case where they're supplementary, which makes sense because those angles are same side interior. So I'm going to set them equal to 180. I'm going to add them up, set them equal to 180. That'll be how we start this one. Figure out what x is. 4x and 4x give me 8x. 40 minus 20 gives me 20. Let me subtract the 20. I get 8x is equal to 160. Divide by 8 gives me x is equal to 20. Now let's take that 20 and plug it back in, make sure that it works before we move on to y, because we don't want to get x wrong, because then we're definitely going to get y wrong. So let's plug it in and check it out. 4 times 20 is 80, plus 40 is 120. And then 4 times 20 is 80, minus 20 is 60. Now that looks good to me because those were supposed to be supplementary, and 120 plus 60 is 180. So I'm going to give myself a check on x. I know that that's good. And now that I've plugged that in, I can use that to help me find y. Because remember, the 4x plus 40, the angle that's 120, is the same color as the 11y plus 10, which means those have to be equal to each other. So now I can do 11y plus 10 is equal to 120. Subtract the 10. Get 11y is equal to 110. Divide by 11 gives me y must be 10. So once again, let's double check our work. Let's plug that back in. 11 times 10 is 110. Plus 10 is 120. And does that work? Yeah, because that matches the other yellow angle, right? So give myself a check there. I know that y is 10. So we had to use those same side interior angles at first. And then our second equation was using the alternate interior angles. All right. Last one. Ooh, we got an x, a y, and a z. Okay. So let's set up our color pattern. See what we're working with. Okay. So what do I have? So I've got some green ones. I've got the 3z minus 60, the 11y minus 1, and the 5x plus 115. Those are all green, but none of them have just the same variables, so I don't think I can solve any of those right away. The lone yellow one is a 5y plus 5, and it's actually the y on this one that there's 2 of. So I think we got to start there. And the 2 y's that we have, the 11y minus 1, that's green, the 5y plus 5, that's yellow. Let's start there. That's a green and a yellow. That means they're supplementary, which makes sense because that's a pair of same side interior angles, and those are supposed to be supplementary. So I'm going to add them up, set them equal to 180. Okay, so 11y and 5y give me 16y. Minus 1 and plus 5 give me plus 4. If I subtract the 4, I get 16y is equal to 176. Divide by 16 gives me y is 11. Now let's plug that back in, make sure that that's good. If I plug that back into the 11y minus 1, 11y times, or 11 times 11 is 121, minus 1 is 120. 5 times 11 is 55, plus 5 is 60. And those two numbers, 120 and 60, do add up to be 180, so I'm going to give myself a check there because I checked my work. Now we should be able to solve for the x and the z. I'm going to go for the x next. That just makes more sense to me. The x is a green, which means I should be able to set it equal to any other green, which includes the 120 I just found. The 5x plus 15 and the 120, those are corresponding angles, which means that they must be congruent. They must be the same. So I'm going to do 5x plus 15. 115 equals 120. Subtract that 115. Get 5x is equal to 5. And 5 divided by 5 is 1. So let's plug that back in, double check. 5 times 5, 5x is 5. Plus 115 is 120. And that matches my other green angle. Those corresponding angles are congruent, so I know that x is 5. Then lastly, we have the z. And the z is green, which means it should be equal to the 120. So 3z minus 60 is equal to 120. Now you can think about that equation a few different ways. The 3z minus 60 is vertical with the 11y minus 1. Vertical angles are congruent. Or the 3z minus 16 is alternate exterior with the 5x plus 115. Those are also congruent. So two different ways of thinking about why we can set up this equation. We add the 60. We get 3z is equal to 180. Divide by 3. And I get the z is equal to 60. So let's plug that back in, make sure that that works. 3 times 60 is 180. 180 minus 60 is 120. So I feel good about that one. Z is, not 120. Z is 60. So you can see it's really important to check your work as you're going along on these ones because they all build off of each other. You don't want to get the first one wrong because then you're going to get all the other ones wrong. So make sure you're taking the time to go back and check as you're going along. Okay, y'all's turn. So on yours, you've got 6 problems here. None of the ones with more than one variable. I just want you to name the angle pair and solve for x. You can come back here when you're done to double check your work. All right, so this first one, those were alternate interior. And then if we're solving, 8x minus 2 equals 6x plus 16. That should have given you 2x minus 2 is equal to 16. 2x is equal to 18. So you should have gotten that x was 9 on the first one. This next one were alternate exterior. Alternate exterior are congruent, so 3x plus 6 is equal to 66. Subtract the 6, you get 60. Divide by 3, and you get 20. For example, 3, those were same side interior. So I'm going to do 5x plus 80 equals 80. Nope. Psych. That's a joke. Same side interior is supplementary. So 5x plus 80 plus 80 equals 180. That's 5x plus 160. Subtract the 160, we get 20. Divide by 5, and we get 4. Number 4 was corresponding angles. Corresponding angles are congruent, so 10x minus 10 is equal to 5x plus 70. Subtract the 5x, we get 5x minus 10 is equal to 70. Add the 10, so I get 5x is equal to 80. And that's going to give me that x is 16. Number 5, we got another pair of alternate exterior here. Alternate exterior angles are congruent, so 36 plus x is equal to 4x plus 9. If I subtract the 4x, I get 36 minus 3x is equal to 9. Subtract the 36, I get negative 3x is equal to negative 27. And dividing is going to give me that x is 9. And our last one here, those are some same side interior. Which means they're supplementary. So 90x plus 5 plus 80x plus 5 is equal to 180. 90 and 80 give me 170x. 5 and 5 give me 10. subtract the 10, and I get 170x is equal to 170, and x is 1. All right, hopefully y'all did well there, and that wraps this video up.